All right, so with number 1, before we even start, what does substitution mean? What does it mean? Like you guys had a substitute teacher on Friday. What does that mean? Guillermo? Replace, exactly. So you're replacing something. So when you're solving a system by substitution, and remember a system is just 2 equations that work together where the variable equals the same thing. So when you're solving an equation or a system of equations by substitution, what that means is you're taking something out and you're replacing it. And in the case of number 1, we've got 2 equations here. The first one says y equals x minus 2, and the second one says y equals 4x plus 1. So what could we replace then? What could we replace? Brennan? With what? Okay, so you can replace something with the whole other equation, right? You can't replace the x because what's by itself right here? Y, so that means you're going to replace the y. So that means in this second equation, we'll call it number 2, in this second equation, instead of writing y, what could we write instead? The other equation, we can write x minus 2. Y is equal to x minus 2, so that means instead of writing y right here in number 2, I'm going to write x minus 2. So my new equation is going to look like x minus 2 equals 4x plus 1. That's the substitution part. All right, go ahead, Brendan.
So what do you solve for once you get that?
Well, now that it's like this, what can I solve for? I can't solve for y because I don't have any y's left, so I have to solve for x. And then once you have that answer, you can plug that back in to solve for y. Okay, so how do I solve for x then? In our new equation, I'm going to call that equation number 3. In our new equation, how would I solve that? What would I do first?
You start off using PIMDAS.
Okay, I can't really do anything with order of operations right now because I've got a couple variables. But what do I have to do with my variables? Get them on one side. And usually I want them on which side? It doesn't really matter, but we'll move this one over here because, Angel, if I move this x over, how do I move a positive x? Subtract, so minus x minus x. What number is in front of here if there isn't one? 1. So what's 4x minus 1x? 3x plus 1 equals what? Negative 2. Good. And then what do I do? I have to do minus 1 because I've got x over here, but I need to get it by itself. So minus 1 minus 1. What's negative 2 minus 1? Negative 3 equals, what do I have left over here? 3x, and then how would you finish that? Divide it by 3 and divide by 3. What's negative 3 divided by positive 3?
Negative 1.
Negative 1 equals x. So x equals negative 1. So with substitution, the first thing you want to do is figure out what you can plug in. And since y was by itself here, and y was equal to x minus 2, that means in the second equation, we can just take out the y and plug in that whole other equation. So then you get x equals negative 1. Now, am I done, or do I need to go back and figure out y? Go back and figure out y. So where do you put the x in? Which equation? Does it matter? It doesn't matter, whichever one's easier for you. So this one has less math in it because it doesn't have a coefficient. So I'm going to plug it into that. So y equals negative 1 minus 2. What's negative 1 minus 2? Negative 3. So then y equals negative 3. Okay, again, that's substitution. So that's what you guys did on Friday, but I understand and I totally get if that's something that was difficult, that's okay, but that means you need to come to office hours, okay? And that doesn't mean that there's anything like I expect you to get stuff super quickly. This stuff takes practice. So I understand if it's something that was difficult, but make sure you don't just say like, okay, whatever, I'm not going to worry about it. You need to worry about it because it's going to be on tests and quizzes. So if it's something like what I just did right there, if you have no idea how that happened, just come to office hours. It's not going to take a long time, but we can do a few practice problems, okay? So substitution gets a little more complicated when you don't have a variable by itself, which is in like 3 and 4. Or I'm sorry, just in number 4, because number 4 is the only one with a variable that isn't by itself. All right, so if we have time at the end, we'll go back and look at that. But because classes are shorter today, I want to get started on what we're talking about today. All right, so we've said that there are 3 different ways to solve systems of equations. The first one we did last week was by graphing. So when you solve a system by graphing, you graph the 2 lines, and then what do you look for? What do you look for? If you're solving a system by graphing, you graph both of the lines, and then what do you look for? Montreal? Yeah, where the 2 lines meet, right? What if they never meet? What if they're like this? They're parallel, and that means there's no solution. Exactly. What if they're on top of each other? All real numbers. Exactly. So graphing is a great way to do it. If you are adept at graphing, and if it's not huge numbers. If they're huge numbers, graphing gets kind of not hard to do, but you just need a really big coordinate plane. Substitution is great if you have a variable by itself, but sometimes if you don't have a variable by itself, substitution gets really complicated. So the last way we're going to talk about is solving by elimination. What does elimination mean? To take out. So if you're in a basketball tournament and your team gets eliminated, what happens? You're out. You don't play anymore, right? So you're done. So elimination is basically like trying to get rid of something or take something out. Solving an equation by elimination is basically trying to get rid of one of the variables so that it becomes a lot easier. So take a look at this system of equations right here, and I'm going to rewrite it right here. So if I have x minus 2y equals negative 19, and 5x plus 2y equals 1, instead of looking at it like 2 separate equations, I want you to look at it like one big problem. I want you to look at it like an addition problem. So if I add these together, what happens to x and 5x if you add those together? 6x. What happens to negative 2y and positive 2y? They're gone. So those cancel out, they're gone. So you don't have anything there. So then what do you have when you have negative 19 and 1? What does that give you when you add it together? Negative 18. So all of a sudden, what happened? When I put my 2 equations together, I added them up, what happened? What happened to the y? It's gone. So now, can you solve this? How would you solve this? Divide it by 6. So I divide by 6, and you end up with what? What's negative 18 divided by 6? Negative 3. So you have your x value. Now what would you do to get your y value? Plug it in to which equation? Whichever one you pick. Honestly, it doesn't matter. Why do you think I would pick this one? What? Everything's positive. So it's a lot easier if everything's positive. So I'm going to pick this equation, and we'll call it equation number 2. I'm going to do 5, but instead of x, what am I plugging in? Negative 3 plus 2y equals 1. What's 5 times negative 3? Negative 15 plus 2y equals 1. Now what do I do? Add 15. What's 1 plus 15? 16 equals 2y. So then how do I finish? Good. Divide by 2, so y equals 8. Great job. Elimination is awesome because elimination makes stuff disappear so that you really only have 2 pretty simple problems to do. Unlike substitution, if we go back to this rewind right here, with substitution, you end up with a lot more math to do than you do in elimination because elimination just makes things disappear. You don't have to plug anything in, it just cancels them out. Yeah?
Isn't that what we've been doing our entire time?
What do you mean?
When we solve an equation.
Yes.
Then why are we learning it again?
It's not learning it again, it's putting together 2 equations now. So it's like what you've been doing, except in this case we've got a system of equations.
Oh, it's 2 equations?
Yeah, these are the 2 equations. So we're trying to solve this system of equations where this is equation number 1 and this is equation number 2. All right, so what happened right here with the 2 y's? They canceled out. How come they canceled out? 1 was positive and 1 was, and the coefficients were both 2, right? So they canceled out really neatly. Do you think that's always going to happen? No, and we're going to look at some problems where that doesn't always happen, but for right now, let's take another look at another problem. All right, here are just your steps for how to do this. Write the system so the like terms are aligned. What does aligned mean? What is, yeah, like this, right? X's should be on top of X's, Y's should be on top of, numbers should be on top of numbers. So a constant should just be on top of a constant. Good. All right, eliminate one of the variables and solve for the other one, and then substitute the value back in to get your answer as an ordered pair. So let's take a look at another example problem. All right, so I'm going to put this on a blank page. Negative 4x minus 2y equals negative 12. Okay, here are my two equations in my system of equations. The first one is negative 4x minus 2y equals 12. The second one is 4x plus 8y equals 24. Do I need to align them, or are they already aligned? They're already aligned. The x's are with the x's, the y's are with the y's, the constants are over here by themselves. All right? Is there anything right now you can cancel out? Guillermo? The 4x. How come those cancel out? One's a negative and one's a positive, but they both are how many? There's 4 in both of them, right? So those go away right away. All right? And then what do you do with your y's? What's negative 2 plus 8?
Oh, you do like terms?
Yeah, you just combine like they're like terms. So you get positive 6y. And then what's 12 plus 24? 36? Oh, it's a negative 12. Thanks. So what's negative 12 and 24?
12.
Positive or negative?
Positive.
Positive 12. Good.
Negative.
They're both negative? Oh, all right. Thanks, guys. So then this would be what?
Negative 36.
Good. Negative 36. Then how do you finish?
You divide 6 by 36 and the answer is negative 6.
Y equals negative 6.
Yeah.
Okay? What's the last thing you have to do?
Plug it in.
Plug it back in. To which equation? Top, bottom, or either?
Either.
Whichever one you want. So Des, pick one for me. 1 or 2? 1? Okay. So negative 4x minus 2, negative 6 equals negative 12. What's negative 2 times negative 6?
Positive 12.
12. So that becomes negative 4x plus 12 equals negative 12. Okay, now what do I do? Get x by itself. So Montreal, how can I get rid of this positive 12? Minus 12, minus 12. What's negative 12 and negative 12?
0.
No.
I mean, negative 24.
Negative 24 equals negative 4x. And then how do you finish? So x equals positive 6, because the negative and a negative become a positive. All right, so then our ordered pair ends up being 6, negative 6. Okay, so elimination works really, really well if you have things that are already opposites with the same coefficients. So what I want you guys to do is try this one at your seats. Only look at this problem.
I'm glad they're already aligned.
Oh, yeah. Okay, so they're already aligned for you, right? Is there anything you can cancel out?
Yes. I mean, no.
It almost looks like you could cancel out the y's, but what's wrong? They're both positive. So what do you think you need to do?
Like terms?
Well, if I add them all together, that's not really going to help me because then I still have 2 variables. I need to get rid of it, but how can I do that?
I think you can put. No, I don't know.
What were you going to say?
I was gonna say put the 8 on top of the other one.
Same thing's still going to happen, though. I'm still going to have both of these are going to be positive. So what do I need? I can't getting rid of the 2 doesn't help me. The 2's not the problem.
You need the division.
What do you mean?
No, you need something other than division or multiplication.
Okay. Why could we cancel out the 4's from the previous problem? One was negative and one was positive. So what do I need here? I need one of them to be negative, right? Well, I can't just make it negative, or can I? You can? Which one, top or bottom?
You can make either one.
You can make either of them negative as long as you do what?
The same
The same with everything in the rest of the equation, okay? So if I want this to be a negative, I can do that. I just have to change this to what? And this to a negative. All right? Yes, exactly. So if it's already negative, it would become positive. Good. Okay, so now can we do it? What happens with the two y's? Those are gone. What's 7 minus 8? Negative 1x. And then what's 24 minus 30? Negative 6. Good. And I divide by negative 1. Divide by negative 1. And you get x equals... What do you get? 6. All right, how would you finish? Which one? Either one. I'm going to pick the top one now because it's all positive. So that goes 7 times 6 is what? 42 plus 2y equals 24. Now what? Get y by itself. How are you going to do that?
Minus 42.
And you get 2y equals 18? 18? Negative 18. How would you finish? Divide by 2. Divide by 2. Y equals negative 9. Okay. Can you change things to negatives? As long as you do what? To the rest of the equation. All right, you can make something a negative as long as you switch the signs for the rest of the equation. What Brendan said is really important. If it was already negative, it would become positive. Okay, go try these 6. Just try 2 of them. Any 2 that you want to try. Okay, so I tend to think this is a lot easier than substitution for a lot of reasons, but for some reason what I found is substitution doesn't feel very intuitive for you guys. Like it seems more complicated maybe than it is. So I think elimination just feels more intuitive, which makes it feel a lot easier. So if ever you can eliminate, do. Okay? On your quiz and test, though, you're going to have to be able to substitute. So don't think like, oh, well, I'll just eliminate everything, because you won't necessarily be able to. And here's another issue with elimination. Right here in this problem, does anything eliminate there? Why not? Yeah, none of them have the same coefficients, right? None of them have the same numbers in front of them, so nothing can eliminate. What we did last time, though, is we said we can make stuff negative, right? As long as you do it to everything else in the equation. So do you think you could change the coefficient of something? Yes? As long as you do what?
As long as you change the y.
Change everything in the rest of the equation, right? So what would you like to change here? What do you need? You need something that's going to cancel out, right? Which variable looks more likely to cancel out? X's or Y's?
X.
Why the X? One of them's already negative and positive. The only problem is that I would need this to be what?
1.
This is a 1 right now. I need it to be a what?
2.
How could you make it a 2? How can you turn a 1 into a 2? You could add 1, but if I add 1, addition doesn't really work because it's not a like term. But what else could you do, Guillermo? Multiply by what? 1 times 2, right? If I multiply this by 2, what do I have to multiply this by? 2. And this? 2. Also by 2. Okay, so you basically get a whole new equation. I do this whole thing times 2. And what process or what property is this? I'm distributing. All I'm doing is distributing a 2. And it doesn't change anything except that now I can eliminate my x's because I'm going to rewrite equation number 1. 2x plus y equals 3. And I'm going to write equation number 2, except I'm going to distribute that. So what do I get when I distribute that? Negative 2x plus 6y equals negative 24. And now I can eliminate, because what happens with my x's? They cancel out. And then what do I have left? Y plus 6y is 7y. And what's 3 minus 24? Negative 21. How do I finish? Divide by, and y equals what? Negative 3. Good. Okay, and then to finish that off, I just go back and plug it in. I'm going to do it to the first one because those numbers are smaller. So 2x plus negative 3 equals 3. I'm going to add 3 to both sides, and you get 2x equals 6. And so that ends up being x equals 3. So my answer then would be 3, negative 3. Okay? So you can always eliminate. You can always eliminate. You just might have to do something first. All right? You might have to do something first to get it to be eliminatable. All right? And again, you can eliminate if the signs are opposite and the number is the same. So sometimes you just need to get the numbers the same. All right. Now, this slide, which you guys have, is the work that we just did. So if you didn't finish copying it down, you already have it in the slide. Brendan.
So you can eliminate and then do substitution?
You wouldn't need to get the other one, yeah. Like to get your second answer, is that what you're saying? Yeah, so you eliminate and then substitute in to get your second answer. But you don't have to substitute from the very beginning. So you're only substituting in a whole number rather than an equation, if that makes sense, or an expression. Okay, sometimes you can't just multiply something by, you can't just multiply one of them. So looking at this one right here, how can I figure out a way that I could eliminate something? Because right now, I don't see anything that I can eliminate. I don't see anything I can eliminate. What do you think? What do you mean?
You can divide 8. I mean, you can divide 12 to make it equal 8.
Okay, but if I do that, what happens to the 7?
You have to divide that also.
Yeah, and then is that going to be a pretty whole number? Or is that going to be an ugly decimal? Probably an ugly decimal. So yes, that would absolutely work. You could divide everything by the same thing. However, I think it's going to be easier if we still multiply. Can I multiply just one of them to get something that, like, does 8 go into 12? No? Does 5 go into 7? No? So there's nothing I can multiply. Do they have anything in common? Like, is there anything that 8 and 12 both go into? 24. So what if I multiplied, what would I have to multiply the top by to make this 24? 2. And what would I have to multiply the bottom by to make that 24? 3. So can I do that? By all means, yeah. This one I'm going to multiply by 2. This one I'm going to multiply by 3. And I just have to multiply straight across. So what's my new top equation? 14x minus 24y equals negative 44. Great job. All right, and on the bottom, I'm multiplying by 3. So what's 3 times 5? 15x minus 24y equals, what's 3 times 14? 42. So negative 42. All right, can I eliminate right now, or do I have to change my signs? Change your signs. So this becomes negative, this becomes positive, and this becomes positive. Okay, so now, what's 14 minus 15? Negative 1. What happens with my y's? All right, so negative 1x equals, what's negative 44 plus 42? Negative 2. Good. How do I finish? Divide by negative 1, and you end up with x equals 2. All right, so I'm going to go back and plug that in, and I'm going to plug it into the second equation because I like 5s better than 7s. So 5 times 2 minus 8y equals negative 14. What's 5 times 2? 10 minus 8y equals negative 14 minus 10 minus 10. What's negative 14 and negative 10? -24. Negative 24. And then negative 8. What's 24 divided by negative 8? Good, y equals 3. Okay, so I want you guys to think back to Thursday, which was the first day you were back. We started with systems of equations. Systems of equations are not easy. All right, but like I said, it's one of the big things when you are done with Algebra 1, systems of equations are one of the big things that you will need to know. So we're going to do this for a long time, and it gets easier like everything else with practice. So if right now this is feeling really overwhelming to you, understand that I totally feel you, I get that, and it will get easier, okay? That said, this also means your tests and quizzes start to get a lot shorter because there's a lot more work for each problem. All right, so you're not ever going to be expected to do like 75 of these at one time. All right, there's a lot of work here. So don't get intimidated by the amount of steps. Just think about it like several different problems. Okay, I am going to give you guys a chance to do one, but I only want you to do one of these at the board. So try one of these at the board.